Well, good afternoon, everyone. My name is Ryan Brooks, and I'm here to give a high-level overview about how to scale or creating and scaling meaningful performance tests in CI. This talk was inspired by many of the tools that I built at my company, Merge Tools, and the learnings that I'll be talking about have come from a lot of trial and error, building highly accurate and meaningful performance tests for our clients that can run on any app. So first is a little bit about me. I'm the Android lead at Emerge Tools, where, as I mentioned, I built out a suite of tools for both size analysis and runtime performance. And I've been at Emerge for about a year and a half now, and I've learned a ton, especially on the deeper, darker Android internals. And before Emerge, I was at Airbnb for about 3 years working on Android. I specifically worked on their server-driven UI platform called Ghost Platform. There's a nice blog post out about it, if you might have seen it before. Which immersed me into the importance of performance at scale. So without further ado, let's get into a quick agenda for today. We'll first establish a base and go over what mobile performance even is, and especially in the context of our app, and touch on different performance metrics that we might want to benchmark and test. From that base, we can then explore a framework for choosing what's actually worth testing. And a little spoiler alert, not everything is actually something that we necessarily want to test or is worth or realistically we even can test in our apps. So after we establish that framework, we'll take a high-level look at all the different tools that we have at our disposal provided by Google to test and measure these metrics. And to bring it all together, we'll talk about strategies for how to scale these performance tests and measurements across an organization, focusing on the different trade-offs and levers that we can adjust for performance testing. So let's go ahead and hop in. So before we talk about strategies for actually measuring and testing performance, we need to lay a groundwork for what mobile performance actually is. So we can know what metrics we can and realistically should measure in our apps. So as a mobile engineer, performance is oftentimes highly correlated with the business case of our apps. For your favorite newsreader, like Hacker News here, the time it takes to launch into the app and start browsing is a very important metric. Too long and users will leave before ever engaging in any content. For a shopping app like Walmart here, getting to a checkout screen needs to be as quick as possible. Slow performance at any stage through a user's browsing process, and they might leave before they end up buying an item, which has a direct business metric impact. And then for a streaming app like YouTube, the time it takes to search for a video, load the video, and actually start playing the video is incredibly important. Too slow, and a user might, again, leave before engaging with any content where they won't actually see the ad that YouTube might have wanted you to see. So while business cases highly drive the performance metrics that we want to measure, let's just go ahead and take the universal case from the previous slide, something that everyone is going to have here, and that's startup time. So I'm going to use Hacker News here as our example of a standard startup flow. A surprisingly large amount of work actually goes on in the quick 4-second video that's already ended on this slide. And we usually like to think of these interactions as one overall macro metric that we want to measure. And in this case, that's startup time. But this specific measure includes a bunch of micro interactions that also take place during this time. So let's break it down into what these smaller measures are so we can build it up to our overall startup time metric. So during our whole startup time path, a ton of things happen. Your process is created, the DEX is loaded, just-in-time and ahead-of-time compilation occurs in the Android runtime. You initialize content providers, SDKs, your application, your view model, your activity, your fragments are all created. Dependencies are injected, data is fetched from the network, and finally all this is rendered into components in the UI. And this all is supposed to take place within about 1 or 2 seconds. All of this crazy amount of work that we have to deal with. We might want to also test each of these things specifically to see what actually regressed as part of our startup flow, if there was something that got slower due to a change or something like that. But realistically, we can't test everything here. And when it comes to performance testing, it's not realistic to actually test all those things and measure these small little pieces. So let's separate these metrics into things that are in our control and things that are outside of our control as mobile developers. So I like to think of things that are actually shipped in the app to be mobile specific. Things that are actually like the DEX or resources that are downloaded by the users as part of your APK. This essentially includes most of our metrics from the previous slide, like the SDK initializations, content providers, rendering for UI, things like that. Things that are out of our control like network requests and communication with other processes are still important to us. But if a network request is slow to load, that's still a bad user experience. It's just not necessarily something that we want to focus our testing on. We would rather focus tracking on that. So taking from all this, it's important to test things that are directly in our control as part of our mobile performance testing suite, and leaving things that are out of our direct control, like network latency, to different forms of testing, or, like I mentioned, tracking, which we won't necessarily discuss today. And in many circumstances, we primarily just want to test that macro measure, being startup time in this case. We don't want to test all the tiny little slivers of interactions that are occurring in this whole 1 to 2 second flow. These micro measures definitely are worth testing, but we have to have there's essentially a trade-off here, that managing the tests for all these micro measures is not necessarily worth the cost associated with managing all these little micro tests. And because of that, it's important to measure the impact of our testing changes too. And to be as impactful as possible, we're really going to focus today on these macro measures. So one thing that I mentioned, but I want to touch on before we get much further, is tracking versus testing. We're focusing today on testing performance to catch regressions before they make it into production. Testing is not a replacement for tracking. Rather, I like to consider it a complement to tracking. Pre-production testing, being testing in CI or on our own devices or things like that, will never be able to give us the full picture that we can get from just the scale alone of production, as well as the diversity and the edge cases that we might get from our user pool. This isn't saying, of course, that testing is not important. In fact, quite the contrary. We can test for measures that catch large regressions and things before they make it into production, but we still need to see production data to paint the full picture of how our app is performing and doing in the wild. So now that we've gone over what we deem to be mobile performance and what we're going to focus on today, I'm going to introduce a framework that I like to follow in determining what metrics we want to test for different flows inside of our apps. And it's important to hone in on some shared characteristics that we want our metrics to share and why we want them to have those characteristics. And the 3 characteristics I like to classify a good testable metric as having is that 1, it's controllable, 2, the metric is reproducible, and 3, the metric is impactful. So let's get into what each of these means and how it pertains to performance testing. We touched on it earlier, but the first criteria for a good performance metric is that it's controllable. To best explain this, let's look a little bit again at that startup example. We already discussed network latency a bit, and that it's not the best mobile-specific metric to test for, but we still have to deal with it when we're testing for performance. As you guys can see, these 2 requests were fired about 15 minutes apart, but the one on the right here was a good 1.5 seconds slower than the one on the left. And nothing at all changed about the state of the phone or the app itself between these 2 tests. The network simply just took 0.5 seconds or 1.5 seconds longer. But if we're performance testing this flow and we recorded the amount of time it took to render all the stories on the screen here, we might have seen this as being a 1.5 second regression, when in fact, it just so happens that a factor outside of our direct control is what actually influenced this. There are, of course, ways that we can get around this, like mocking or replaying the network things, but we'll get into that in a minute. The second criteria for a good performance metric to record is that it's reproducible. So following that Walmart example from earlier, one of our core business metrics at Walmart might be to load the buy now modal. Users expect fast and snappy checkout, and if they don't get it, they might exit before they actually complete their purchase, which directly affects our business metrics in the end. Any regression in our performance here could result in a significant business metric impact. So we might want to create a performance test to test how fast this loads and to make sure that any new changes that we introduce to the app does not slow down this page. Sounds like a pretty good test, correct? Not necessarily, though. This test here is actually relatively non-deterministic without some workarounds. So the product in that previous example was a Pixel 6 Pro case. The product in this situation, clicking the top item in our performance test, is actually a Pixel 6 Pro, the actual phone itself. Again, nothing changed about the app in this situation or the phone itself. What happened in between was that the search ranking actually reordered the items in our list. So our performance test that clicked the top item and then recorded how much time it took to load the buy now modal is now showing a completely different item. We might have seen this, in this situation, this one loaded about 0.5 seconds slower. we might have seen this as now as a half a second regression to our buy now flow, which is not correct at all. It's just due to the non-determinism of the way that our UI test was set up. And there are, of course, ways to work around this, like I mentioned for startup a minute ago. Like we can launch a deep link into a specific product to ensure that the same product loads every time. Or we can mock the network response to make sure that the news feed is the same every time. But both of those assumptions assume that we've actually built out a system for deep links, or that we've built out a system for network mocking or network replay or something like that. And suddenly, if we don't have those already implemented, adding this performance test now has ballooned the scope of our project. We now have to implement some sort of deep linking capability or network mocking or something. And that might not be realistic for the constraints that we tend to have as engineers. So all I wanted to do was test the performance to check out, and now suddenly if I have to create a mocking system or something like that, I'm not going to want to add a performance test anymore. And finally, your time as a developer is limited, and testing every single micro interaction is not practical. It would also be just a losing game to chase the performance of every single micro thing that's occurring in your app. So let's say we wanted to test the time it took for a user to expand a video's description in YouTube. It looks like my GIF messed up, unfortunately. You can pretend that someone clicked the description here. How impactful is it necessarily if a user's tap on the description on YouTube took just a little bit longer than it did before? Would a user ever even notice, first of all, given that something else is playing, something relatively more important is playing on the screen, the video itself? Or would any business metrics actually be impacted by how fast that the description loads? It very well could, and for some situations that's the case. I would imagine in this case for YouTube, opening the description probably does not have any business metric impact. So it's important to think through the impact of our performance tests and the performance metrics we want to record on the actual business metrics of the product itself. It's not necessarily important to test every small thing in our app, and it's important to hone in our time and resources on the major things. So let's use this same criteria to filter out some example measurements, just to reiterate what we've talked about. Let's avoid testing non-controllable measures, like things like network operations without mocking, or interactions where other processes other than our app that we're reliant on. Network operations are definitely something we want to track, but not necessarily a good candidate for performance testing. So again, we will get much better data from production than we will in testing. We also want to avoid non-reproducible tests, like testing with dynamic content, such as search results that can easily change. And finally, in a perfect world, we would test just about everything on our app if we could, but we're limited by time and resources and people. So we want to avoid testing non-impactful or non-primary user flows for our product or our business case. Examples of things that might not be impactful are usually driven by the specific app itself, but an easy classifier are things that aren't primary user flows or primary interaction where performance might also be masked by some other thing that's going on the screen at any given time. So let's move into the implementation of what we just covered. We'll take a glance at some strategies and tools that we can use to accurately measure and test our app's performance. So in the past few years, we've seen an explosion in high-quality measurement and testing tools that have become available on Android. And I like to separate these into two buckets, those for measuring and those for testing. I'm going to get a bit opinionated today from my personal experience of many of the tools above, and there's quite a few more that aren't included that I'm leaving off intentionally to try and give you some guidance on what is most useful as it pertains to performance testing. And like I said, there are many more out there than just on this list, but this narrows down from my personal experience running around with many different tools and validating the performance and accuracy of all of them. So in addition to that, I've crossed out two more from the list above. And so for the Android Studio Profiler, that's primarily for one-off tests. It's definitely a very useful test. I think the Android Studio team is working on this quite a bit as we speak to improve it more. And it even uses the same tool under the hood that I'll actually get into in a few minutes, which is called SimplePerf. On the testing side, we've removed Espresso, as that's not actually a viable candidate for performance testing, as it attaches itself directly to our target app's process, which can significantly actually affect the performance of our target app itself. So that's an important note, is that we want our testing to be separate from our actual app itself. So let's look at the tools that we use to measure performance and how those can influence how we might test afterwards. So two primary strategies that you might hear with performance testing revolves around tracing and revolves around sampling. And it's worth briefly touching on both of those. Tracing is using explicit start and stop points to timestamp specific events that are occurring in our app. Tracing can be as detailed as you might like. You can add start and stop points for the activity's creation or for a view's rendering. Or you could add a start and stop point for every single function call inside of your app. Marking start and stop points takes time though, and doing thousands to millions of these in an app, especially for every single function, can actually have a significant impact on the performance of your app yourself. So it's kind of contradictory that us wanting to measure the performance of our app can actually negatively affect the performance of our app. Sampling, on the other hand, is essentially taking a snapshot of the computer's state at a given time. That's often done with snapshots or like a call stack snapshot to see what functions are actually being executed at this snapshot in time. And snapshots can be taken just like tracing as much as you would like. You can take one a second, or you can take one every half of a millisecond. And similar to tracing, the more snapshots we take, that actually has a performance impact on the overall computer or device itself. Too many snapshots, and suddenly our data that we're trying to measure is polluted, and simply by the tool that we were using already to measure performance in the first place. So which one should we choose, given that both of these have their own trade-offs? I personally believe in combining the two methods here. Using a combination of less detailed tracing and also medium detail sampling gives us a very good ability to record the span over a start and endpoint, and then see what all is happening during that endpoint with a more detailed view of sampling. And so the first measurement tool I'd like to talk about is Perfetto. And in my opinion, Perfetto is probably the most powerful tool that's offered as it pertains to mobile performance measurement. How many people in here have ever used Perfetto before? I like to see some hands. That's good. That's good. If you've used Perfetto before, you might have seen this, and this is pretty scary. This is just a simple recording of a random app that I took, whose startup that I was wanting to measure and see how long it took. Under the hood, Perfetto leverages internal Android and Linux tracing and performance tools. It provides quite a lot of additional tools, like a web UI you see here for visualizing the traces you see above. And this can oftentimes be overwhelming, but hopefully this will give you an idea of how much data Perfetto can actually record. It produces an incredibly detailed amount of data. You can see we have like CPU frequency and state. We have memory state. You can actually see certain spans inside of all the app's processes that are occurring inside of at your phone during the given time window, et cetera, et cetera. I won't discuss all this stuff in detail. There's quite a few resources out there for parsing Perfetto traces. But in my opinion, where Perfetto really shines is that it actually has a SQL layer above it. And a simple example here shows us querying what's called a slice in Perfetto. And there's a few slices specifically that this specific query right here pulls out. And this assembles basically what we declare a startup time to be. The query on the left just selects your application's process and queries like the Zygote init, which is the process start, the bind application, which is where your onCreate occurs, and then the first frame. So this would be time to first frame. And assembling these by the simple query on the left, we get a timestamp and a duration. So the timestamp of the start and then the duration can give us an idea of, we pinpointed the process starts at a certain time, and then we pinpointed that the due frame ends at this specific time, and then to figure out how long our startup is, take the end point and you minus the start point. And so now suddenly we've been able to very, very accurately determine the amount of time it took for our app to start up. This is actually what tools like Macro Benchmark and the Google Benchmark libraries use under the hood. They use this SQL layer on top of Perfetto to actually get their startup and duration, frame metrics, things like that. So I want to sum up all the tools as we go through them one by one, just so we'll do a quick pros and cons list of each. We'll start with Perfetto. So Perfetto really shines in its SQL layer. Almost all the data that I showed you in that screenshot of Perfetto is exposed through SQL itself, which allows us to build rich queries to pull the data and actually do interesting processing on that data from the traces themselves. Perfetto is also very well documented and well supported by Google. And in addition, Perfetto has a very little performance impact, depending on your use case, of course, on the app itself, as it's just aggregating traces that are performed at a system level. So it's not a major concern when we're measuring performance. But Perfetto does bring some cons with it. Perfetto is primarily used for tracing, like we talked about earlier. And it's worth noting that Perfetto does not do sampling. Theoretically, it can sample, but unfortunately, there's some issues inside of Perfetto and some lacking support for actually aggregating samples, so being that snapshot in time that I mentioned earlier. And so we are missing a critical part of the picture that's occurring in our app at any given time. Finally, Perfetto has a high learning curve for some of its tooling. That screenshot earlier didn't demonstrate that at all. And it's quite daunting when you first get into it. But if you leverage the SQL layer and go slowly, I think that it can actually be a very easy tool to pick up. So, like I mentioned, Perfetto is awesome for collecting traces and their durations, but tracing is only part of the performance battle. If we want to get an even deeper look into what's going on in our apps, we can also sample the methods that are called during the execution of the test. Has anyone here used SimplePerf before? I did not expect to see many hands for that. SimplePerf is a tool that the Android Studio Profiler actually leverages under the hood to profile your apps. It leverages Linux perf events, if you've ever heard of those before, hence the name. It's basically just a wrapper around the Linux perf events. And that helps us to produce call stacks of every single function that's running during the profiling process. So while Perfetto traces, SimplePerf samples. And combining the two, we can get the slices from Perfetto with clear start and stop timestamps. And then we can also get the samples from SimplePerf. So all the methods that we were calling in our app, like the Java code or the Kotlin code directly, and we can assemble a full picture of what's occurring in our app at any given time. From there, SimplePerf offers a ton of useful scripts to convert the generated profiles to various flame graphs, such as Brendan Gregg's folded format or Gecko profiles, which you can view using the Firefox profiler. Sampling, of course, like I mentioned earlier, does have a small performance hit, but this performance hit is one that's relatively minimal and it's like a lever that you can kind of adjust. It can be mitigated by just adjusting SimplePerf parameters. And then further, these flame graphs can be further transformed to produce diff flame graphs, which provide a visual representation for what changed between specific function calls. And this is one thing that's extremely important in performance testing, is highlighting the specific things that change, and we'll get into that a little bit more in a bit. This is personally where I think most of the power of flame graphs really shines. When we can diff them and use a color scheme or something of that manner that reflects the changes in specific function calls, we can actually pinpoint the specific change to what occurred in code. And I think that in a development cycle, when we're able to actually pinpoint a performance change to a specific function that we might have written as part of a PR or code change, I think that's where it gets incredibly useful to performance test in CI. I want to explain how to generate these. BrendanGregg.com. Brendan Gregg is the creator of the flame graph. I would recommend visiting that website for a lot of resources on how to process and use flame graphs. So to sum things up for SimplePerf, let's go through some pros and cons like we just did with Perfetto. So for the pros, SimplePerf samples all the methods during our sample period, giving us the best view of everything that's occurring in our app. It also comes with a ton of helper scripts that allow for conversion to common formats such as the Brendan Gregg's folded format or Gecko profiles. I personally use the .folded format because it's well documented and there's a lot of support out there for it on Brendan Gregg's website. And finally, these helper scripts can handle deobfuscation, symbolication, demangling, things that we often take for granted when we're doing performance testing or crash tracing or something like that. But on the downside, SimplePerf is a sampler. So essentially recording every function call can actually affect performance results, but that frequency, like we mentioned, can be adjusted to mitigate that issue. SimplePerf is also very poorly documented. Much of my experience using it came through trial and error, and the documentation for it is actually in the Android open source project, which is kind of tough to find sometimes. Finally, going along with poor documentation, configuring and adjusting some of the levers in SimplePerf is cumbersome, and many of the parameters tend to be hidden. I've actually had to dive into the C++ implementation of SimplePerf to figure out all of the options that you have at the disposal. So maybe that could be worth a blog post or something, is documenting it. I also want to briefly touch on the idea of comparing performance results before we move on to how to actually test our apps next. The whole purpose of performance testing is trying to catch regressions and improvements before they make it into production. And the only way that can be done is by comparing results of our performance tests. So no matter which way we choose to measure performance, if it's just Perfetto, if it's just SimplePerf, if it's both, or if it's some other method entirely, it's extremely important to have a comparison. We need to take whatever change that we're trying to measure as the experiment and whatever change we're trying to measure against as the control. In this case, most use cases, that could be anything like a release versus a release. So if we wanted to see if version 2 got faster or slower than version 1, that's our experiment and that's our control. Or you could do it on every single PR, where your PR might actually be the experiment and your base might be the control being main. It's important to also use relative comparisons when we're talking about a performance test, rather than an absolute change, like milliseconds. So let's say we choose to test on a Pixel 6 Pro and we detect a performance change. That Pixel 6 Pro could have wildly different performance metrics compared to like a Samsung Galaxy S5 from years ago. And there's a good chance you'll still be able to see a change on your Pixel 6 Pro or your Galaxy S5. It's just the magnitude of the change might be bigger or smaller. So percentages are very important to measure here. And so differences between measurements should be calculated as a percentage. And finally, we'll touch on this shortly, but collecting and comparing sampling data like flame graphs allow us to pinpoint specific changes in performance to specific functions in our code, which is the most important thing for educating developers on what to change to actually fix performance issues. So overall, for performance measurements, I use a combination, like I mentioned, of SimplePerf and Perfetto, combining the SQL elements of SimplePerf to get timestamps and then using that to filter down my windows of time with SimplePerf. But measuring is only half the game. How should we actually run the tests to test our performance metrics without affecting the performance of the app itself? So I want to touch on the most difficult problem to solving performance testing in production, and that's variance. You could run startup for your app now, and then I could move across the room and run it again in 15 minutes and potentially get wildly different results, all because of factors like thermal state, CPU clocks, etc. When added to the performance testing mix, variance now can prevent us from getting accurate results, even if the device is in the same place and just tested 1 minute later. And so to mitigate this problem when you're performance testing, we need to try and control as much of this variance as possible. And there's two primary ways that we can do this. One is we can mitigate variance by obtaining a large enough sample size of measures, which will allow us to both trim the outliers and to leverage the law of large numbers. The second is to control as much as possible about a run, like locking clocks, clearing page cache, mocking network requests, and much, much more. This will ensure that the state of the device and the app is as similar as possible across future runs, giving results that aren't prone to other factors that influence performance results. So the first testing tool that I want to introduce is Macro Benchmark. I think many people in here might have heard of Macro Benchmark before. Great. I see a lot of heads nodding. So I'm a big fan of Macro Benchmark, and it pulls together much of what I have talked about and provides methods to counter variance directly incorporated with it. So Macro Benchmark is a library that was created by Google that allows for benchmarking performance metrics at scale. A quick sample above shows how easy it is to configure a startup test with iteration count, startup mode, compilation mode, etc. Many people might have already heard about Macro, especially for baseline profiles. I won't touch on baseline profiles today, but those can also be generated directly from the same test that you write here. So Macro Benchmark leverages Perfetto under the hood and uses the SQL layer of Perfetto that I mentioned to gather performance data when you're profiling your app. And so to control variance, Macro Benchmark leverages a separate test APK that runs against your main app to separate the performance benchmarking out of the app's process itself, which is an important thing to note. Macro Benchmark helps to get performance benchmarks up and running as fast as possible, providing tons of functionality behind the scenes to make controlling our testing much more accurate without doing any work on our part. Macro Benchmark also outputs results in JSON and the Perfetto trace directly itself, so you can even write your own SQL queries against the trace that's outputted. But with all the freebies that Macro Benchmark provides, it can get a bit restrictive in times, especially if we need more customization on what Perfetto configurations we're recording, or for adding sampling, like we discussed earlier. And that's where UI Automator will come in. So I think it's good to hit some pros and cons of Macro Benchmark as well. Firstly, that's the pros. As we've shown, Macro Benchmark is incredibly simple to set up. and by far the fastest to get off the ground for measuring performance results. It provides lots of freebies like managing variance behind the scenes, and then generating the JSON and Perfetto results that we can even use in addition to calculate our own performance metrics. So much of the complicated aspects of testing are abstracted away, like running multiple iterations, managing variance, logging clocks, etc. Macro Benchmark does all that behind the hood. In addition, it can also generate baseline profiles, like I mentioned, which I've heard can actually have a significant impact on startup time. I haven't explored them too much myself personally, but I know that they're very, very hot right now, so I would recommend checking them out. But it does bring some cons too, of course. It's inflexible to larger demands, like if you need to measure additional metrics above the default provided ones by Macro Benchmark. It also controls variance, but to a point. Like I mentioned, it does automatically drop page caching, it ahead of time compiles for you, things like that. But if you need additional variance control, if your tests are getting flaky, you're going to have to manage some of that stuff yourself, like locking CPU clocks or deeper variance control methods. And finally, Macro Benchmark doesn't provide sampling built in to generate flame graphs like we've talked about. The benchmark library does actually have SimplePerf built into it, or a SimplePerf profile that should be able to be leveraged, but I've actually never personally gotten this working myself, and it's not documented very well, unfortunately. It very well might work. Maybe it's my fault, but nonetheless, it's prevented me from actually getting valid sampling results from Macro Benchmark code, which, as we talked about earlier, pinpointing function changes or performance changes to specific methods or code that changed is extremely important in the performance testing realm. And so the final testing tool that I want to introduce is UI Automator. And UI Automator, like all of our other tools, is a framework that's built and maintained by Google, and I think that it's a must for performance testing. It's what's leveraged by Macro Benchmark for actually running performance tests. Other test methods, such as Espresso, attach themselves directly to our app's process, but UI Automator actually runs in its own test app itself. Usually Macro Benchmark will cover most of our performance benchmarking use cases, but if you need to go deeper with what Perfetto or SimplePerf are recording, you'll need to leverage Macro Benchmark for your testing needs. And I won't go into too much detail about how to write UI Automator tests. It's well documented by Google, and I would recommend checking out that documentation for it. And so for a quick summary of UI Automator, it gives us the full flexibility that we might need if we're going into deeper performance measurements that we can leverage through Perfetto or SimplePerf. It still leverages many of the elements of the benchmark libraries and allows us to use some of the freebies that Macro Benchmark and the benchmark library itself provides. But then in addition, you can still use additional methods if you need to control variance and things like that. For cons, while doing everything manually gives you full control, it also requires you to do everything manually. So now the barrier of entry is much higher and the barrier for maintenance is much higher. You'll also have to manually run all of your measurement tools, such as Perfetto and SimplePerf yourself. So I personally lean to a custom implementation myself. As in my personal experience, Macro Benchmark is really good for getting off the ground and getting basic metrics like startup, frame hangs, things like that. But as soon as you need to go a little bit deeper and customize, like getting CPU usage, getting memory usage, things like that, Macro Benchmark has fallen apart for me in the past. And so that's where I leverage personally a manual Perfetto, SimplePerf, and then UI Automator combination for my tests. So we talked a lot about the methods for measuring and testing performance, which in my opinion is actually the easier part of performance testing at scale. And now we'll get into what I personally believe to be the harder and more dynamic part to be, and that's scaling the performance tests to run across an organization. So as with testing and measuring, we'll get into some high-level strategies to run perf tests at scale, but before that I want to talk to a general concept that I've seen in my experience with performance testing and CI. And so there's three primary trade-offs at hand when you're scaling performance testing across an org. That would be cost, accuracy, and speed. And so we'll go ahead and break these down more. So there's many levers that you can pull and adjust to fit your team and org's needs. The type of device you choose to test on might affect cost and accuracy of your perf testing. If you wanted to test on the latest and greatest Pixel 7s, that's going to cost a lot of money to get enough Pixel 7s to run all your performance tests on. And also might not represent the diverse spread of devices that your users will actually use. Choosing to run on physical devices as well over emulators might also affect cost and accuracy, as well as how you orchestrate the actual tests that you're running. The cadence that you run performance tests at and the scale at which you run them will also influence the number of devices that you might need. So if you choose to run every single commit on every single PR, and you have 100 engineers in your organization, you're going to need a lot of devices to cover the amount of performance tests that you're going to run, which again increases cost and affects the speed of your performance tests. You can also choose the number of iterations that you might want to test, which can make performance tests faster to run if you do less iterations, but less data and less performance information will prevent us from being able to filter out outliers, which can also affect your overall performance results. And so there's many levers that you can pull to control perf testing in the configuration behind it, but each has some sort of trade-off that we might have to accept as a consequence of our decision. And of course, last but not least, we've at least established how to measure, test, and scale, but how do we actually deliver actionable results so that we can quickly address and fix performance issues, or reward someone for improving performance in that matter? The first aspect of delivering results is to pinpoint the source of the change. Running perf tests at a PR level makes it easy for us to directly identify the source of change for macro benchmarks, and oftentimes finding the source of change is the easiest by simply looking at the diff. Sampling all of the methods running during a perf test is the most detailed strategy that we can apply, as it allows us to diff the flame graphs that we record and to highlight differences in the specific duration of functions. Showing those results to developers can be as easy as posting them directly to GitHub or GitLab, posting to Slack, sending alerts to someone's email, or things like that. And this is highly dependent on the source control and CI setup, so I won't go too in-depth about how to do that here. But an example would be to use like a GitHub status check that might block you or something if you increase performance by too much. So I did go over a lot today. If there's anything that you might have learned, is that perf testing is extremely complicated and quite hard. And so I want to sum up everything real quick just to make sure that we hit on all the high levels that we talk about today. So the first step in performance testing is determining what we will test and why. So again, we should follow our framework that I introduced in determining what are good candidates for perf tests, or metrics that we want to test. And that would be that the metrics are controllable, reproducible, and impactful. The second step in determining how we will test those metrics. We went over many tools at our disposal to measure and test to give us actionable and accurate results, like Perfetto, SimplePerf, Macro Benchmark, and UI Automator. And finally, we went over, in my opinion, the most difficult part of performance testing, and that's scaling the performance test across an org. We went over perf testing trade-offs, how the cost, accuracy, and speed are the three most determining factors when running perf tests at scale, and how we can adjust those to fit all of our needs. We also went over ways to front the performance testing results to give real and actionable results directly in our developers' workflows. And so it should be evident now, performance testing is quite hard, and much of my experience that I shared has come from my experience working at and scaling performance tests at Emerge. We do have quite a few solutions that will make performance testing far easier for you and your team, so if you're interested, just let us know. But nonetheless, with all that concludes my talk. I'd like to thank everyone for attending today, and I think we might have like 1 or 2 minutes, and I can open the floor for questions. But of course, if we don't have time, feel free to come up afterwards. I'll hang around for a few minutes, or feel free to email me or follow me on Twitter or follow Emerge on Twitter. But thank you guys for coming.